Let's take a look at example 3, topic 7.2. We're going to find the coordinates of a point on the unit circle. And let's start off by taking a look at that word unit. Unit means one. So in this instance, when we're talking about the unit circle, that means we're going to have a radius of 1. And that radius is also going to be our hypotenuse. We're going to create some right triangles on our unit circle. Also, when we're on the unit circle, we're on a coordinate plane. And you guys know we have X and Y coordinates. Well, now in trig on this unit circle, we are going to have cosine of theta and sine of theta. Those will be our ordered pairs. And again, it's the same as an XY. And you can remember this too, just like XY, alphabetical order, cosine, sine, C comes before S, we're in alphabetical order. So your cosine values will relate to your horizontal, and your sine values are going to relate to your vertical. So we're going to start out, I'm going to show you the 3 most common reference angles that we'll be using. And if I give you, let's do 60 degrees. So 60 degrees is right here. And what I'm going to do is I'm just going to draw a line perpendicular to the x-axis. This is like my x-axis. Here's my y-axis. We now have a right triangle, and we know the hypotenuse is 1 because the radius is 1. And now let's think back to our special right triangles. This is angle theta. Theta is 60 degrees. So I'm going to go off to the side here, and let's just kind of sketch that in. So remember, this is 60 degrees. We have a 30, 60, 90 right triangle, and the hypotenuse is 2x, where x is the short leg. Here's 30 degrees, opposite 30 degrees is your short leg. So your hypotenuse is 2 times the length of your short leg, and then the long leg, which is always across from the 60 degrees, is your short leg times the square root of 3. Now we already know that the hypotenuse equals 1 because it's on the unit circle. So let's see what we get for x. 2x equals 1. X equals 1/2. So that means here, my distance, that horizontal distance from the origin is 1/2. And if I multiply square root of 3 by 1/2, I get the square root of 3 over 2. Now, I'm looking for a coordinate on the unit circle where my 60 degrees here, this ray is intersecting the edge of the circle. And remember, your x is your distance from the origin, and your y is the vertical height away from the origin. So this is the ordered pair 1/2 square root 3 over 2. And let's do 30 degrees. Okay, so now 30 degrees is right here. And again, I'm going to draw that line perpendicular to the x-axis. And here's my theta. Theta is 30 degrees. And again, let's do that right triangle trig. Take this off to the side. So now I've got the 30 degrees is here, which means 60 degrees is here. So my short leg is x. My long leg is going to be x times the square root of 3. And again, my hypotenuse is 2x. Well, we just did this. So we know that the hypotenuse is 1, which means now here's my short side, so that is 1/2. And now my long leg is going to be 1/2 times the square root of 3. So now we are at square root of 3 over 2. So the ordered pair here is my cosine, square root 3 over 2, and my sine is 1/2. And again, what this means too is when you're asked to evaluate cosine of 30 degrees, cosine of 30 degrees is the square root 3 over 2. The sine of 30 degrees is 1/2. And if you notice these, notice how they're flipped. And that is because 30 and 60 are complementary angles. So the cosine of one angle equals the sine of the other. And we see that right here where our cosines are flipped and our sine values are flipped. And let's do one more, 45 degrees. This is the easiest one. Okay, 45 degrees is right here. And again, I'm going to create that line perpendicular to the x-axis. A radius of 1. Here's my angle theta at 45 degrees. Let's carry this over into right triangle trig. In a 45, 90 degree triangle, your sides are congruent, the legs are congruent, and the hypotenuse is x times the square root of 2. And again, I know that my hypotenuse is 1. So let's solve for x. I'm going to divide both sides by the square root of 2. I don't ever want to leave a radical in the denominator, so I'm going to multiply top and bottom by the square root of 2. We're going to rationalize that denominator, and we get square root of 2 all over 2. So that means this leg here, square root 2 over 2, and this here is square root 2 over 2. So again, that ordered pair, my distance, my horizontal distance, square root 2 of 2, and vertical is square root 2 over 2.